Hey guys, welcome to Chem Galaxy. So in the last lecture I have discussed about the n factor calculation of acids, bases, atoms and homonuclear polyatoms. Alright, so if you haven't watched that video, the video is appearing on the iCard, you can check it out. Alright, now in today's video I am going to continue my topic of n factor, and in today's video I am going to discuss how to calculate the n factor of cations, anions, alright, salts and oxidizing agent and reducing agents. Alright, so stick around, the video is very important for all of you. Alright, so now let's start. So as you all can see, the heading is n factor calculation. So first of all I am going to discuss the calculation of n factor of cations and anions. So basically what is the n factor of cations and anions? Basically the charge on them. Alright, the charge which the anion or cation is containing, that is the n factor of that ion. Alright, so that's what I have written also, that the charge on the ion is its n factor. Alright, so let us see some examples, then it will be more clear. Okay, so the first example is Fe2 plus. So you see in Fe2 plus, it is a ferrous ion. So basically you see the charge on it is 2 plus. Alright, so the n factor is 2. Note this point, that n factor is only a number, it does not have any sign. It is only a number, it always have a positive sign. Alright, so keep this point in mind. So the ferrous ion has 2 plus charge on it, so the n factor is 2. Now in ferric ion, the charge is 3 plus, so the n factor is 3. Alright, now carbonate, so in carbonate ion you see the charge is 2 minus. Alright, so the n factor will be 2. Alright, in Cl minus or chloride ion, the charge is minus 1, so the n factor is 1. Now in the last example you see it is an oxalate ion, so the charge on it is 2 minus, so the n factor will be 2. Alright, okay, I hope this is clear to you. So now let us see the n factor of salts. What is the n factor of salts basically, and or how can you calculate the n factor for salts? So the total positive charge or the total negative charge on the salt is known as its n factor basically. Alright, you know that salts are neutral in nature. Alright, they are neutral. So the total positive charge on the salt or the total negative charge of the salt is known as its n factor. So let us see some examples, then it will be more clear to you. Alright, so you see the first example is, see my cursor, the first example is sodium chloride. Alright, it is a salt. Alright, now you see the total positive charge, if you see, so the positive charge will be accumulated on sodium ion, and the sodium ion will have a +1 charge on it, right? And the total negative charge, if you want to see, so the total negative charge will be accumulated on the chloride ion and it will have a -1 charge. Alright, so that basically the total positive charge of the sodium chloride salt is 1, right? So the n factor of sodium chloride is 1. Alright, now in the second example I have taken ferrous sulfate. Alright, so the total positive charge on the ferrous ion will be 2 plus, right? And the total negative charge on the sulfate ion will be 2 minus. So basically the total positive charge on the overall salt is 2 plus, right? The total positive charge is 2 plus and also the total negative charge is 2 minus. So basically what will be the n factor? 2. Right, because the n factor is total positive charge or the total negative charge of the salt is its n factor. So the total positive charge on ferrous sulfate is 2 plus, so the n factor will be 2. Alright, now the next example is magnesium hydroxide. So again same thing. Now the total positive charge on magnesium is 2 plus, because you know that the hydroxide ion has always negative charge on it. Alright, always -1 charge on it. Hydroxide ion always have -1 charge on it. So here there are 2 hydroxide ions attached to magnesium. Alright, and overall it is a neutral species, right? So 2 negative charges are attached to magnesium. So to compensate that or to neutralize that 2 negative charges, the magnesium should have a 2 plus charge on it. Right, so this is how you can basically calculate the oxidation state basically. Alright, so the magnesium, the total charge on magnesium will be 2 plus, because there are 2 OH minus attached to it and the 2 OH minus has -1 charge each. Alright, so total minus charge will be -2. So to neutralize that -2 charge, the magnesium should have +2 charge on it. Alright, so the total positive charge on the magnesium hydroxide will be +2, so the n factor will be 2. Alright, Now you see aluminum chloride. All right. So in aluminum chloride, you see that the 3 chloride ions are attached to aluminum. All right. Chloride ion will have a negative charge, -1 charge. There are 3 chloride ions, so total of 3 negative charges, right? So to neutralize that 3 negative charges, aluminum should have +3 charge on it. All right. I hope this is clear. So total positive charge on the aluminum chloride is 3. Total negative charge on aluminum chloride is 3. So N factor will be 3. Alright. I hope this is clear. Now last example is aluminum sulfate. Alright. Now here you see. Okay. So aluminum will have +3 charge on it. Alright. I hope this is clear. And sulfate will have a -2 charge on it. Okay. So now you see. Now one sulfate ion has -2 charge on it, right? Now there are 3 sulfate ions attached. All right. So total of -6 negative charge will be there. All right. So and the overall molecule is neutral, right? So to neutralize that -6 charge, the aluminum should have a +6 charge, right? But not a single aluminum atom can have +6 charge. So you see there are 2 aluminum atoms, right? So there will be a total of +6 charge on it. All right. Each aluminum atom will have a +3 charge on it, right? So there are 2 aluminum atoms. So the total of +6 charge will be developed. All right. So in overall aluminum sulfate, if you see, the total positive charge is +6 and the total negative charge is -6. So the N factor will be 6. All right. This point should be kept in mind, that always take the total positive charge or the total negative charge. Okay, so the sulfate has -2 charge on it and there are 3 sulfates ion, so there will be a total of -6 negative charge on it, and overall it is a neutral species. All right, so there is a total of -6 negative charge on it, so the N factor will be 6. All right, so you can either calculate from the total negative charge or you can either calculate from a total positive charge. All right, it is up to you, whichever way you are comfortable with. Okay, all right. I hope this is clear to you. Now let us see the N factor of oxidizing agent and reducing agent. All right. So concentrate on it. So because it is very important. And so the N factor of oxidizing agent and reducing agent is total change in oxidation state per molecule. All right. This point should be kept in mind, that the N factor of oxidizing or reducing agent is the total change in oxidation state per molecule. All right. This per molecule is very important. So keep this thing in mind. All right. So the total oxidation state of total change in oxidation state of oxidizing agent or reducing agent per molecule. All right. So let us see some examples, then it will be more clear. All right. So the first example you see, this is potassium permanganate. It is a very good oxidizing agent in acidic medium, basic medium, as well as in neutral medium. All right. So if we basically react potassium permanganate in acidic medium, then it forms Mn+2 charge compounds. All right. Basically such type of compounds in which manganese have a +2 oxidation state. All right. So whenever potassium permanganate reacts in an acidic medium, it forms such type of compounds in which manganese will have a +2 charge on it. All right. So that's what I've written. So KMnO4 in acidic medium, it will give such compounds in which manganese has +2 charge. Basically I have not written the whole reaction because we are only considering determining the change in oxidation state. All right, which happens. So we know that the potassium permanganate in acidic medium reacts and forms a compound having Mn+2 type of compound. All right. So we can easily determine the change in oxidation state. So we know in Mn+2 the oxidation state is +2. Now what is the oxidation state of manganese in potassium permanganate? So let us calculate that. All right, then only we can be able to calculate the change in oxidation state, right? So what is the oxidation state of potassium permanganate? What is the oxidation state of manganese in potassium permanganate? All right. So oxidation state of manganese in potassium permanganate is what? So potassium will have a +1 charge always. All right. The group 1 elements always have a +1 charge on it. All right. So it will have a plus charge. We don't know the oxidation state of manganese. So let us assume it to be X. All right. So see my cursor. So 1 of potassium plus X, because we don't know the oxidation state of manganese, we need to calculate that. and plus 4 times minus 2, because the oxygen will always have a minus 2 charge except in peroxide and hyperperoxides. Alright, except those, the oxygen will always have a minus 2 charge on it. Alright, so basically it is minus 2 charge and there are 4 oxygens, so that's why I have multiplied it by 4, and overall it is equal to 0 because overall potassium permanganate is a neutral species. Alright, so now let us calculate it. So 1 plus x minus 8 equal to 0, so x comes out to be 7. Alright, so this means that the oxidation state of manganese in potassium permanganate is plus 7. Alright, now when it reacts, it forms a compound in which the oxidation state of manganese is plus 2, right? So what is the overall change per molecule? Alright, so what is the overall change per molecule? So from plus 7 to plus 2, alright, so there is a change of 5 oxidation number, right? So the N factor of potassium permanganate in acidic medium will be 5. Alright, so that's what I have written also, that change in the oxidation state per molecule is 7 minus 2, which is equal to 5. So N factor of potassium permanganate is 5. Okay, now let us see the reaction of potassium permanganate in basic medium basically. Alright, so potassium permanganate in basic medium forms this compound, alright, K2MnO4. Okay, so now, so the N factor of potassium permanganate in basic medium is 1. Alright, so how? Let us see. So you know that the oxidation state of manganese in potassium permanganate is plus 7 as calculated above. Alright, now let us see what is the oxidation state of manganese in K2MnO4. Alright, so what will be the oxidation state? So see my cursor, you see 2 times 1 I have written because there are 2 potassium atoms attached. Alright, and one atom will have a plus 1 charge, so 2 into 1, alright, plus x, because we don't know the oxidation state of manganese, so I am assuming it to be x. Alright, and oxygen will have a minus 2 charge and there are 4 atoms, so 4 times minus 2, alright, equal to 0 because it is an overall neutral species. Alright, so 2 plus x minus 8 equal to 0, so x comes out to be 6. So this means that the oxidation state of manganese Mn in K2MnO4 is plus 6. Alright, now in potassium permanganate the oxidation state of manganese is plus 7. So when it reacts in basic medium, it gives a compound in which manganese has an oxidation state of plus 6. So basically what is the change in oxidation state? Of 1, right? From 7 to 6. So there is a change of 1 only. So the N factor will be 1. Alright, I hope this is clear to you. Now let us see what is the N factor when KMnO4 is reacted in neutral species. Alright, so basically this point should be kept in mind that in acidic medium potassium permanganate the N factor is 5. In basic medium the potassium permanganate the N factor is 1. Alright, now in neutral species the N factor is 3. Alright, how? I will tell you, don't worry. So you see now the oxidation state of manganese in potassium permanganate is plus 7. Alright, now in MnO2 the oxidation state of manganese is plus 4 because you see the oxygen will have minus 2 charge on it. There are 2 oxygen atoms, so total of minus 4 charge. Alright, so and MnO2 is a neutral species, so to neutralize minus 4 charge, manganese should have a plus 4 charge on it, right? I hope this is clear. So from plus 7 to plus 4, so there is a change of 3 oxidation state per molecule, right? There is a change of 3 oxidation state, alright, or 3 oxidation number. So the N factor will be 3. Alright, I hope this is clear to you. Now let us see another example. It is a very good example, so concentrate on it. So you see here I have taken ferrous oxalate. So when it reacts, it gives ferric ion and carbon dioxide. Alright, so now what will be the N factor of ferrous oxide or ferrous oxalate? Sorry, it is ferrous oxalate, not ferrous oxide. So when ferrous oxalate reacts, it gives ferric ion and carbon dioxide. So what is the N factor of ferrous oxalate? Alright, so let us see. So you see here in ferrous oxalate I am saying ferrous, so this automatically means that the iron is having a plus 2 charge. Alright, because in inorganic naming, if the iron is having a +2 charge, then it is known as ferrous, and if it has a +3 charge, it is known as ferric. Alright, this point should be kept in mind. So the in ferrous oxalate, the ferrous ion has +2 charge on it, and it is converting to ferrous 3 plus. Alright, so there is a change of 1 oxidation number. Alright, now it doesn't ends here. Alright, now the carbon is also having a change in oxidation number, so you have to check each and every atom. Alright, so now you see in what would be the oxidation state of carbon in this whole ferrous oxalate thing. Alright, so let us calculate that. Okay, so what is the oxidation number of carbon in oxalate ion? So this is how you can calculate it. So you see, we don't know the oxidation state of carbon, so I am assuming it to be X. Alright, and there are 2 carbon atoms, so basically 2X, see my cursor. Alright, so 2X plus 4 into -2, alright, because oxidation state of oxygen is -2, 4 atoms are there, so 4 into -2, and equal to -2 because the oxalate ion has an overall charge of -2 on it. Alright, so it will be equal to -2. Okay, so now let us calculate it. So 2x minus 8 equal to -2. Alright, so 2x equal to 6, so x equal to 3. Alright, so a single carbon atom in the oxalate ion will have a +3 oxidation state. Okay, it will have a +3 oxidation state. Okay, now you see that when the ferrous oxalate reacts, it gives carbon dioxide. Alright, now what is the oxidation state of carbon in carbon dioxide? Alright, so the oxidation state of carbon in carbon dioxide is +4. Alright, because the oxygen will have a -2 charge, there are 2 atoms, so -4 charge overall. Alright, it is a neutral species, so carbon should have a +4 charge to neutralize that -4 charge. Alright, so the carbon will have a +4 charge. So basically you see that a carbon goes from +3 to +4. Alright, so there is a change of 1 oxidation number, but I have told you that the N factor is the total change in oxidation state per molecule. Now in the overall molecule there are 2 carbon atoms. Alright, so a single carbon atom is going a change of 1 oxidation number, so 2 carbon atoms will go a change of 2 oxidation number. Alright, so 2 carbon atoms will go a change of 2 oxidation number. Alright, so the overall change of oxalate ion is 2, right, and the overall change of ferrous ion, ferrous to ferric, is 1. Alright, so total change of ferrous oxalate is 1 of ferric, of iron, and 2 of oxalate. Alright, so total change is 3, so the N factor is 3. Alright, so that's what I have written also, so concentrate on it. Alright, so you see that the oxidation state of carbon in carbon dioxide is +4. Alright, so change of oxidation state of one carbon atom is 1. Alright, as there are 2 carbon atoms in a molecule, so total change is equal to 2. Alright, because the change in oxidation state per molecule is the N factor. Alright, so we need to calculate per molecule. That's why we have considered 2 carbon atoms, because in the whole molecule there are 2 carbon atoms, not a single carbon atom. So we have calculated the change in oxidation state of 1 carbon atom, and now we will, with the help of that, we can calculate the change in oxidation state of 2 carbon atoms, which comes out to be 2. Alright, so the total change in 2 carbon atoms in a molecule is 2. Alright, so total change in oxidation state per molecule of ferrous oxalate, what will be the total change in per molecule of ferrous oxalate, because we need to calculate the N factor of ferrous oxalate. So basically iron is giving a change of 1 oxidation number, and oxalate is giving a change of 2 oxidation number. So total will be 1 plus 2, which is equal to 3. Alright, so you see 1 plus 2 equal to 3. So basically the N factor of ferrous oxalate is 3. Alright, I hope this is clear to you. So that's all about N factor. Alright, so I hope this is clear to you. So that's all for today. I hope you have understood whatever I have taught. If you have understood, do give it a like, subscribe to my channel, and if you have any queries, comment down below. Alright, so now I will see you all in the next video. Till then, this is Akash Shukla signing off.